So we continue now going over IHD. So the first one here, calculate the IHD of C6H10NO2Br. So IHD is given by 2N plus 2 minus H divided by 2. So this is going to give us 2, the number of carbons, so that is 6, and then plus 2 minus. Now we have got how many hydrogens here? There are 10 hydrogens for question 1. Now when you're talking about halogens, we always get to add the IHD. So do we have any halogen? We have got one halogen, bromine, so that will be plus A1. And then oxygen, for those elements which are in group 6, oxygen, sulfur don't affect IHD. And then for those in group 5, they always subtract from IHD. So I've got a nitrogen there, that will be a minus 1, and then divided by 2. This is going to give us, of course, this and this will cancel. 2 times 6, that is a 12, plus 2, 14, minus 10, that is going to be 4 over 2, that will be a 2. So that is going to be it. Now let's consider B. So for B, that is going to be IHD being equal to 2. We are substituting again in the same formula. The number of carbons, they are 14, plus 2 minus the number of hydrogens, they are 21. How many halogens do we have? Okay, we know halogens always get to add IHD. We have got 6 chlorines. And then phosphorus, there are 3 of them, they always get to subtract. Oxygen doesn't affect, it's in group 6, divided by 2. And this is going to give us 2 times 14, that is a 28, plus 2, that will be a 30. So 30 inside the brackets here, 6 minus 3, that will be a 3, and 3 plus 21, that will be a 24. So that will be 30 minus 24, which is a 6, and divided by 2, that is going to give us a 3. So that is an IHD of 3. And how about C? So IHD is given by 2N plus 2 minus H divided by 2, and this would be 2N, there are 5 carbons there, plus 2 minus the hydrogens, there are 9, and then we have got a nitrogen, it always subtracts, minus a 1 divided by a 2. So 9 minus 1, that's 8. 2 times 5, that's a 10, plus 2, 12, minus 8, that is a 4 over 2. That is going to give us a 2. So let's consider now here, calculate the IHD. How do we calculate the IHD for the one on top there? Well, we already know the formula. IHD is given by 2N plus 2 minus H over 2. So we need to identify how many carbons are present in this molecule and also how many hydrogens. So carbons, 1 here, 2 there, 3 there, 4, 5, 6, and 7. So there are 7 carbons. Then plus 2 minus the number of hydrogens. So each carbon is supposed to be bonded to 4 things. So already there are 2 bonds here. So there are 2 more hydrogens there. So there are 2 hydrogens there, 2, 4, 6, 8. But here there are 3 bonds, so we only need 1 hydrogen, 8, 9. Here there are also 3 bonds, so you only need 1 hydrogen, 10. Also, now here don't need any hydrogen because there are already 4 bonds, 3 this side, 1 this side. So that is just a what? A 10. And then divide by 2. So 2 times 7, 14 plus 2, 16 minus 10, 6 divided by 2, that is giving us a 3. Let me do that again. 2 times 7, that is a 14, plus a 2, that is a 16, minus a 10, that is a 6. Okay. And then 6 divided by 2, that is a 3. So an IHD of 3. And we can just count this even without looking at that. When you have got a ring has got 1 IHD. A double bond, 2 IHDs. Okay, I mean a double bond, one IHD. A triple bond has got two IHDs. So there's a 2 there and then a 1 here, giving us a 3 as we have also calculated. A single bond doesn't have any IHD, 0. A double bond has got only one IHD, so you can even tell there will be one IHD here because we only have one double bond. Well, we can confirm that IHD is going to be equal to 2, the number of carbons, 1 there, 2 there, 3 there, 4 there. And then plus 2 minus the number of hydrogens, there will be 3 here, 4, 5, only 1 here, 6, and then 2 here, 7, 8 over 2. So this is 8, this is also 8. 2 over 2, that's a 1. So that is going to be it. And then for this one, the IHD is going to be equal to 2, the number of carbons, 1, 2, 3, 4, 5. So we can tell that the IHD is going to be 0 plus 2 minus, because there's no double bond, there's no ring. The number of hydrogens, there will be 3 here, 4, 5, 6, 7, 8, 9, 10, 11, and then there will just be 1 here, 12 over 2. 2 times 5 is a 10, plus 2, 12, minus 12, 0 over 2, that's a 0. So 1 IHD means we have got 1 ring. If not 1 ring, then we have got 1 double bond. Now when we have got 2 IHDs, this means we can have 2 rings without a double bond, or we can have 2 double bonds, or we can have 1 ring and also 1 double bond. When you have got an IHD of 3, just like that, we can also talk about that. Well, an IHD of 2 can also mean we have got 1 triple bond. But an IHD of 0 means we don't have any triple bond, double bond, or ring, just an alkane. So one of the following compounds is an alkyl and the other a ketone. Identify them. So we are able to identify that by calculating the IHD. We know that for a ketone, there's a double bond with an oxygen. There's an R group this side and R group this side. That's a ketone. So because there is a double bond, we should have at least an IHD of 1. But for an alcohol, we don't have any double bond in an alcohol. So we expect that the IHD is going to be 0. So let's calculate the IHD for the first one. That will be 2 times the number of carbons, which is 5, plus 2 minus the number of hydrogens, 12. Oxygen doesn't affect, divided by 2. That will be, this is a 10 plus 2, 12. 12 minus 12, 0 over 2 is 0. That is for this one. And then for the second one, IHD is going to be equal to 2 times the number of carbons, 4, plus 2 minus the number of hydrogens, 8, divided by 2. 2 times 4, 8, plus 2, 10, minus 8, 2, divided by 2, 1. So IHD of 1, this means this one is a ketone. And then this one is an alcohol because of the IHD of 0. So importance of hydrogen deficiency, which is called IHD, is used to identify whether a compound is going to have a double bond, a single bond, a triple bond, or is going to have a ring. So we can use it to identify also compounds by looking at the formula, because the formula doesn't really tell us how the bonds are going to be. Thank you so much for watching this video. Enjoy your day.